Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3A. We'll be presenting a lab M6, which is a different electrolyte concentration. This is our abstract for our experiment, which is the experiment demonstrate the electroplating by applying the metal coating into the different substrate. The electroplating involve depositing metal onto the substrate using the electric current for to enhance the properties of like the corrosion resistance and also the hardness. The setup that includes an electroplating cell, which is an anode, metal to be deposit, and also the cathode substrate in the electrolyte solution. We plated it in the experiment like a mild steel and ferro, which are varying plating duration to observe the weight and the coating differences. The measurement is also include initial and the final of the coating properties, deposition rates, and also effect of the plating time, offering the insight into the electroplating application. So this is the introduction for our experiment, which is electrolysis is an electrochemical process where an electric current drive a non-spontaneous chemical reaction. So which is the process is crucial for transforming electrical energy into the chemical energy, which is enable a various industrial application. The industrial application that we got is various industries from manufacturing and also a construction to electronic and also automotive sector, which is understanding that optimization of the electrolysis process can contribute significantly to advancing the technology and also meeting in the industrial demands efficiency. So the material that we use is that we'll use is ionos and my steel plates. So the electrolyte that we use is sodium carbonate. Why we use the sodium carbonate? Because it is more active than salt and also can assist the ionization, which is bring more current into the electrolyte. So the process that we have here is two. First, electroplating mechanic, and the second one is role of the anodes, which is the electroplating mechanic is a metal ion from the electrolyte that transfer to the substrate which is cathode due to electric current. These ion are reduced at the cathode or forming a metal coating. So for the roll anode is often made from the plating metal, which is dissolved into a electrolyte to replenish a metal ions. So this is our procedure for our experiment. So for the first one is we prepare the electrolyte solution. So we dissolve a 3, 6 and 9 spoons of the sodium bicarbonate in a 1000 milliliters beaker of in the distilled water, and to create a three type of the solution, which is have a different concentration each itself. So for the next part is we prepare the electrolyte solution. The first one is we fill the beaker with one of the prepared electrolyte solution. After that, we measure and record the initial mass of the mild steel plate, and then we stir the electrolyte which the glass rod to have the electrolyte distribution in the solution. And then we connect an iron nail to the anode, uh, and connect it to the positive terminal, and also the mild steel plate which is at the cathode, and connect to the negative terminal of the power supply. Then we set the power supply is into the 25.56 watts, and start electroplating or maybe electrolysis for 10 minutes, and then for 30 minutes. For each duration, we turn off the power, and then remove the mild steel plate, and rinse it with a distilled water, and we dry thoroughly. So next part is we record the final mass of the mild steel plate. Repeat all this step, which is the variable amount per spoon of the sodium bicarbonate, which is a 3, 6, and 9 solution. So we have a three type of the concentration, and also three type of the weight at the end of the experiment. So after that, for the finalization is do a data recording. So we record the initial and a final weight of the my steel plates for each electrolyte, and also concentration. And after that, we analyze mass difference to determine the ion deposition.
So now I will talk about result. So there are two results. So first one is 10 minutes experiment and the second one is 30 minutes experiment. So we use three different concentration of sodium bicarbonate. So the first one is 3 tablespoon, 6 and 9 tablespoon. So for the initial weight, uh, the first one for the mild steel is 56.92 gram and it is same for all the experiment. And next one is iron in. We have 9.25 gram, 9.18 gram, and also 9.06 gram. So for the final weight, we got difference weight for uh, every specimen. So for the weight difference for the 10-minute experiment, my steel weight increased by 0.25 gram, nail weight decreased by negative 0.15 gram. Uh, for 6 tablespoon, my steel weight increased by 0.5 gram and nail weight decreased by negative 0.2 gram. And for the 9 tablespoon, we got my steel weight increased by 0.75 gram and the nail weight decreased by negative 0.45 gram. So next we move to 30 minutes experiment. So we look at the weight difference. So we see that the weight difference is bigger than the 10-minute experiment. So for the 3 tablespoon, we got my steel weight increased by 0.5 gram, uh, 1.0 gram, and 1.5 gram as we increase the concentration. So for the nail weight decreased by negative 0.3 gram, negative 0.6 gram, and also negative 0.9 gram. So we can see that if the concentration increase, the nail weight or the iron will decrease uh, more large. That's all from me.
Okay, for the calculation, the half reaction we get is ferrum 2 plus 2 electron, then we get the ferrum. So area of the nail submerged is the formula 2 pi RL plus 2 pi R square equal 2 pi times by 0.1 times 2 plus 2 pi times 0.1 the power of 2, and we get the area is 1.3194 centimeter square. So for the current value, the formula is current density plus area. So the current density we get is 1 times by the area that we get earlier. We will get current is 1.3194 A. A is for ampere. So next we calculate the charge Q equal to current I times by time. So the charge we get is 791.64 C. The next one is the mass of my steel deposit M, and the value that we get is 0.262 gram. So next, the volume of my steel deposit, we get the volume is 0.0292 centimeter cube, and the increase of in thickness is 221.4 micrometer. So the increase in thickness is 221.4 micrometer, which is greater than the minimum value 50 micrometer. So the final thickness, when we add the initial thickness, we get a 1221.4 micrometer.
Okay, for the observation, first at low concentration, which is 3 spoon of soda bicarbonate. So what we can see is the electroplate layers were thinner and dull. Uniformity was poor. We are also, it appeared to be a random and came out uneven in pores due to lack of sufficient metal ions in the electrolyte, and the color lacked its richness and luminosity, which attests to its poor quality. For the second one is a moderate concentration, which use 6 spoons of soda bicarbonate. This procedure was found to make a visibility improvement to the quality of the electroplate layer. Samples treated with this solution offer superior and shinier surface finish. A significant trend was observed in the thickness of the metal layer, which significantly improved the planar nature of the substrates. And for the last, a high concentration which used the 9 spoon of soda bicarbonate. This was the highest overall quality. So the thing that we see is the surface look unusually polished and shiny with equal gray color intensity on the entire exposed area, and a further ion layer that was thicker and added better to the substrates. That's all.
Okay, so I'll present about the discussion. So according to the experiment, electrolysis takes place between an ionosyl and mouthstill in a solution of sodium bicarbonate with the ionosyl serving as the anode and the mouthstill as the cathode. Where electricity flows through, the anode undergoes oxidation, causing ions to be discharged into the solution. These ions travel through the electrolyte to the cathode, where these ions are reduced and deposited into mouthstill. The sodium bicarbonate solution acts as a medium for ion transfer and helps in maintaining electrical neutrality in the system. Besides, the bicarbonate ions might also participate in secondary reactions and thus stabilizing the pH value of the solution. Moreover, sodium bicarbonate is an appropriate electrolyte because it's not corrosive and can break down into ions to assist in the flow of current. So, by understanding the fundamental electrochemical reactions and practical setup, this experiment shows essential principles of electroplating and electrolysis, therefore providing valuable insights into material science and engineering applications. The picture below shows example of electrolysis process. Okay, so I'll present about the discussion. So according to the experiment, electrolysis takes place between an ionosyl and mouthstill in a solution of sodium bicarbonate with the ionosyl serving as the anode and the mouthstill as the cathode. Where electricity flows through, the anode undergoes oxidation, causing ions to be discharged into the solution. These ions travel through the electrolyte to the cathode, where these ions are reduced and deposited into mouthstill. The sodium bicarbonate solution acts as a medium for ion transfer and helps in maintaining electrical neutrality in the system. Besides, the bicarbonate ions might also participate in secondary reactions and thus stabilizing the pH value of the solution. Moreover, sodium bicarbonate is an appropriate electrolyte because it's not corrosive and can break down into ions to assist in the flow of current. So, by understanding the fundamental electrochemical reactions and practical setup, this experiment shows essential principles of electroplating and electrolysis, therefore providing valuable insights into material science and engineering applications. The picture below shows example of electrolysis process. For the second question is what ions are present in electrolyte? So the dissociation of sodium bicarbonate NaHCO3 in this solution is shown in the equations below. NaHCO3 breaks down into Na plus sodium ions and bicarbonate ions HCO3. And the next one is in cathode reduction process occur. And if iron ions are present in solution due to oxidation, iron ions will be reduced to form solid ions. At anode, iron undergoes oxidation, which is Fe breaks down into Fe2 plus 2E. Okay, so the answer for the next question is there are two chemical reactions that occur in this experiment, which one at cathode and other one at anode. So half reaction at cathode will be Fe2 plus 2E minus will be F to Fe. So half reaction at anode will be Fe breaks down into Fe2 plus 2E minus. And if water reduction occurs, it will be 2H2O plus 2E minus. It will break down into H2 plus 2OH minus. Moving on with the next question, which is question D. The answer will be, to begin, the concentration of metal ions, which is iron ions, in the solution may increase as iron is oxidized at the anode. Besides, the solution change color slightly due to the presence of dissolved iron ions. So from the experiment, it's observed that the color of the solution turns yellowish and then to dark yellow, as shown in the picture below. Moreover, the pH value of the solution could change if hydrogen gas occurs at the cathode and also producing hydroxide ions. In addition, gas bubbles are observed at the cathode and as hydrogen gas is produced. Moving on with the next question, which is question D. The answer will be, to begin, the concentration of metal ions, which is iron ions, in the solution may increase as iron is oxidized at the anode. Besides, the solution change color slightly due to the presence of dissolved iron ions. So from the experiment, it's observed that the color of the solution turns yellowish and then to dark yellow, as shown in the picture below. Moreover, the pH value of the solution could change if hydrogen gas occurs at the cathode and also producing hydroxide ions. In addition, gas bubbles are observed at the cathode and as hydrogen gas is produced. The answer for the next question, E, which is yes, there is final weight differences observed as the weight of mild steel sample increases due to deposition of metal from the solution onto the surface of mild steel. The differences in weight change depends on the duration of electroplating and amount of current applied. Different materials might show varying weight changes due to differences in their electrochemical properties, such as their ability to gain or lose electrons. Lastly, iron shows decrease in weight is because the iron is oxidized during the electrolysis process, which is the new.
Now I'm going to represent the conclusion of this experiment. As we saw in the introduction, the aim of this experiment was to conduct the electroplating principle through different types of materials, especially the iron and the milled steel. Since the electroplating is the process of producing coating through a metallic surface using the action of the electric current that goes through an electrolyte solution. That's mean if you need to conduct this experiment, you need an electrolyte solution, and that's why we have decided to use sodium carbonate as the electrolyte solution, and it has effectively worked for us and gave us the exact right results and calculations. That was the first principle. The second principle is the Faraday's laws of electrolysis, and the electrochemical cell setup. And both of them, they have huge impact on the results and the calculation, taking the consideration of the temperature and the voltage source, the current source, and the emerge time as well as the reduction and the chemical actions that goes during the experiment. They were all in the consideration, and we have applied them successfully, and they gave us the coating that we need. Then we have to then the aim was to differentiate the coating properties based on two designed electroplating process diameters, and they were also applied successfully and had been done. Thank you.